Good afternoon and welcome to HES's webinar series. Today we have Outback Power's Kendall Schmidt, who is going to be doing a presentation. It's actually part two of his presentations on battery-based grid tie systems. He's going to be reviewing more of the technical side today with two basic examples, one of AC coupling with SolarEdge and also a diesel generator three-phase options with storage. If you have any questions during the webinar, feel free to type them in. We may answer them either privately or at the end of the training, where we'll do a Q&A. As this is technically a little bit more more of a review on technicals, there will be a longer Q&A at the end of the training. Other than that, I think we're ready to go, and welcome, Kendall.
Thank you so much. Well, thanks for attending today, and hopefully we can get you guys a little started down the road to AC coupling with SolarEdge. A couple other things I'm going to cover would be three-phase options with energy storage, essentially either doing a diesel reduction type of program. I know in Canada there's quite a few diesel communities, places that pretty much run on diesel all the time, as well as other modes that allow you to, for instance, augment the AC source, like a three-phase diesel generator with a battery system. So we'll start out here talking about AC coupling. Basically, the concept of AC coupling has been around since grid tie inverters first came out about 10 years ago. And really what it is a way to put backup or energy storage into a system that is a PV system that is grid direct. So you could call it a battery retrofit. But you know, here we talk about moves the renewable energy to loads or to the grid via an AC bus. Essentially, all that's saying is that there's a common point of connection on the AC side with the grid tie inverter, and with our charger. And we control which way that energy goes. When you have a grid tie PV system, as you know, by UL 1741, you actually have to turn that system off if there's a power outage. And despite the fact that it may be a sunny day and you may be making power on the roof, you have no backup. For us, we've always provided backup, even going back to the days before Outback, when many of our people here were working at Trace. The whole concept was either off-grid or battery-based type of stuff. So a few years ago, we essentially decided to make a product that made it easier for someone to add batteries to these types of systems. I'll go through a little bit about how it was done before that as well. And then in this presentation, we're not going to talk particularly about our standard AC coupling load center. We're actually going to talk about a special application with the SolarEdge inverters, where we have a co-branded solution that essentially allows us to access their power reduction port and slowly displace that energy rather than just a hard on-off. There's a little bit of cost savings in that AC coupling system as well. And so depending on how familiar you are with SolarEdge or whether you use another inverter, this may be a good option for you. So what's the motivation behind it? I mean, there's a million of them. You know, maybe you've got diabetes medicine that is in a refrigerator, can't go bad. Maybe you just want your lights and your beer fridge to be on when the power goes out. Or you may be like me at the end of a circuit and power goes out frequently and it's just annoying. For Outback, some of the things that in the recent years have been huge with growing the energy backup market have been things like Superstorm Sandy, the 9-state outage. I think it actually affected parts of Ontario as well, when a power station went down in the Ohio River Valley and created a domino effect. In California this summer, they're expecting rolling blackouts. Things like that. Everybody sits up and takes notice. You know, when your power stays on all the time and it's super cheap, there's really no reason to have a backup system. But when those things change, suddenly we realize how connected to our grid and our electricity we are, and how much we require it all the time. So Typical grid tie inverter. Very simple system. You've got an inverter that essentially all it's going to do is recognize an AC source, and it's going to dump every bit of current that it can into that AC source. And since the grid can take a huge amount of energy being dumped into it, up until a certain point, grid tie systems can just go in no matter what, no need to think about anything else. And again, if you don't have power outages, maybe you don't need backup. But when you do need backup, this is how you used to do it. You would take an autoformer to get your 120, 240 out of a 120 inverter. The whited out inverter, it says Outback VFX FX down below. That's a single leg inverter. And essentially that would be acting as a UPS with the battery. When the grid tie inverters went down, you'd actually go ahead and begin pulling off of that battery just like a backup system, and you would use a diversion load control in case of overproduction from the grid tie inverter when there is no loads, grid, or battery space to be able to put that power into. Today, the typical system just looks like this, and everything that you see here from the PV, the grid tie inverter, come down here, you got your main load, your meter, and your grid. That's a grid tied system. You take this line and all you're doing is just cutting it, and you're giving yourself a critical load panel, a battery, and an Outback system. We do this with very minimal parts. Obviously, you don't need charge controllers. Your production is controlled here in the grid tie inverter. The icon looks a bit like an SMA. Today we're talking about SolarEdge. When the grid goes down, we basically show a sine wave to that grid tie inverter, making it believe the grid is still there. Therefore, it keeps on producing. We use it to power loads, charge the batteries, etc. If the PV is not there and the grid's not there, we're strictly a UPS style system, and we're using the batteries to power that critical loads panel. So let's talk about the SolarEdge in particular. So this is a single line diagram. If you recall what we just looked at a moment ago, I mean, this is pretty much the exact same thing. You've got your array, you've got your inverter going to the main panel in the grid. Soon as the power from the grid stops coming in, we go ahead and flip that relay, and we're operating just on this portion over here. Now, when the grid is up, one key point here is we are just a wire. So there is no efficiency lost in your grid tie inverter sending the power to the grid. It's only when the power goes out that we're doing anything with this. So it's an important thing to remember for the efficiency of those guys. Now, this one's probably a little bit busy to look at here, but this is part of our application note. And when you do this system, you'll want to have our application note handy. There's quite a bit more in there that I won't necessarily go into here that'll be able to help you out. So essentially, there's a couple different ways to look at this. What we're seeing here is the insides of our load center, essentially. These are our busing systems. You got your AC neutral bus bar, DC negative. We're essentially using a relay. This is similar to what we would have used for a diversion control relay in the past, but this relay is operating on a voltage signal, and when the voltage on the batteries climbs to a certain point, you know, say 59, 60 volts, what we're going to do is we're going to introduce a delay there just to make sure it's not a momentary thing. And if that gets to 1 minute of too high of a voltage, this relay is going to be told by our AC coupling mode in the Mate3 that it needs to open that relay and stop accepting power from the SolarEdge. In this case, instead of just opening a relay and dumping that power, what it actually does is it controls the power reduction port, and it takes it from 100% down to 0% on the timeline that SolarEdge likes to see when the power is turned off in their inverter. Now, if we go on to this next slide, you can see that this is essentially what this is pictorially. This is the same busing system down here. This is the load center that you would use for this application. If you're doing a normal AC coupling application, this is a pre-populated load center, all pre-wired, with your relays and your remote operated circuit breakers here, and you just basically are landing your wires at that point. Now, with the SolarEdge system, you don't need all that extra wiring. It's actually a pretty simple standard box, and you're strictly using that relay to tell it to turn off, and so you don't need any of the motorized circuit breakers and those type of things. Additionally, you save a couple $100 by getting this load center rather than the pre-wired. So now, real quick, I want to kind of go through the wiring part of this. This is probably where you're going to have some questions. I say it's easy, you know, at the beginning. The expectation is that you're used to doing some wiring, so there are a couple pieces you actually have to put together. So first, on the SolarEdge inverter, the power reduction port is attached to the board when you open up the inverter. And some of them have this PRI connector already attached. Most of them, I believe, have that in the box. It's a very basic, forget if they call it a 9-pin. There's a couple different sizes, but that should be an easy enough thing to source. And you basically are going to make sure that that is attached to the power reduction port on the board in the actual SolarEdge inverter. And then make sure that the male connector can attach to the load center via that OBR-16 relay. Now, for inside the Radian, in your load center, you're going to put the OBR relay in the load center. You're going to need to put a DIN rail strip in there for it to mount to, and then you basically just attach the pin both to the SolarEdge and to the load center via that relay. So the simplest way for this to work, and I will throw out a couple other options here that I'm not going to necessarily go into that are a bit more complex, but if you need some guidance on those, we're happy to help as well. But the easiest way to do this is to put this into AC coupling mode within the Mate 3. There's basically about 5 buttons you have to push. You're going to go into the inverter section, and you will scroll down to where it has AC coupled. When you press that select button, it's going to ask you whether you want it to be enabled, and you will say yes. And what it's going to do at that point is automatically look at the voltage, and based on the batteries that you have, the voltage, when it climbs too high, is going to flip that relay into an off position after the delay that you put in there. And there can be, depending on your loads, depending on how they work, when they come on, so on and so forth, there can be some variation on how long that delay would be, both for turning the SolarEdge inverter off as well as back on. So now, before I go further, I want to just kind of whet your appetite a little bit here. I'm not going to dive into it, but there are a couple of other pieces to this that are worth thinking about. First of all, this can be stacked. If you have multiple SolarEdge inverters, you can certainly stack them with multiple Radian inverters. Now, another thing to think about, whenever you're AC coupling, you're going through our charger rather than our charge controller. Now, an AC charger is not going to control the charging of the batteries as perfectly as a charge controller would. So one of the things that you can do is you can replicate essentially what a couple different stages of charging would be by actually having a couple different relays that fire at different voltages. And so you can actually, instead of going from 100 to 0 on the production from the SolarEdge inverter, you may decide to go from 100 to 50 or 60, depending on the output that you're after, to replicate an absorbed charge on the batteries. So there's a lot of variation you can do here and some things that can really make this system work differently. Now, the way we just went through it, we were talking about using that diversion load control relay to fire the AC coupling command. You can actually go a different way with this using our FlexNet DC to actually fire differently on different voltages. And again, you can, if you go that route, probably a single inverter to a single inverter, the way that I'm presenting here is the easiest way to do it. If you do have any stacked systems, get a hold of HES, get a hold of us, and we'll go ahead and walk you through it. Set up a half-hour webinar or something that will cover those pieces. I'm sure that wasn't entirely clear. Hopefully, we can answer some of the questions at the end and catch everything else afterwards. So I also wanted to talk to you about some of the options that we have with our three-phase systems, some of the things you can do with these. We have a pre-wired three-phase system that essentially comes in 10 kilowatt building blocks, 10 kilowatts of continuous output power. When we're talking battery-based systems, we're not talking about the size of the PV array necessarily. The size of the PV array could vary extremely, and the output of the inverter could remain at 10 kilowatts. Same thing with the battery. The amount of storage that you have could vary significantly. So with these systems, they do all have a standard 208 volt output. So I know that you guys have plenty of 480, 600 different three-phase systems up there. So keep in mind that if you are talking about those, you very likely will need some transformers on the input and the output. As well, these systems can be stacked up to 3 of them in series. For a total output of a little over 30 kilowatts. You can go up to 32.4. Another little piece there is that these do handle about double the surge. So you can go to 65 kilowatts on your actual surge requirements, depending on what equipment you may have hooked up to these things. So just to go into some of the ways that these have traditionally been used, we've seen everything from, an off-grid mill, lots of refrigeration type of setups. Traditionally, you could only you could not do 9 of these in a system, and you could not go grid connected. So these were typically either off-grid or strictly battery systems. But today, you can go grid connected, and you have the full suite of modes available to you to use. Now, what that means is that as the utilities get more and more creative with their billing mechanisms, such as time of use, demand charges, peak, off-peak, mid-peak, different schedules they may put someone on, our power systems are getting much more agile and being able to manipulate those billing mechanisms to make sure that the customer is spending the least amount of money possible on those systems. So we'll talk just about a couple of these different possibilities here. For commercial applications, go here. So the normal method for using batteries in the past and still today is for backup. Obviously, there's a lot of different reasons that companies or individuals may want or need backup. With our homes, I know that we can all think of about 5, 10 things right off the top of our head. Being without back, I can tell you that I hear about a lot of other reasons. Agriculturally, the milk chillers, those come up all the time. If you've got a farm and you're producing milk, then they only pick it up, say, once a day, and you've got to keep that stuff cold or it goes bad. So if the power goes out for 4 or 6 hours, a dairy can lose a whole lot of money based on just that chiller not working. So that's something that agriculturally we back up very often. Refrigeration of another sort is probably the number 2 reason people have backup. Mom and pop grocery stores, think about all the refrigeration they have. Restaurants, mini marts, things like that. Phones, computers, that sort of thing can very often have a massive commercial impact on a company if the power goes out, as well as servers. With our system involved, you probably wouldn't even notice your computer flickering if that's what you're backing up. You can still make the phone calls you need to continue with your business. Security systems is also another huge one. Plenty of buildings are required to have backup for their security or their emergency lighting and so on and so forth. And you can actually use an outback system to interact with all of that as well. Now, the exciting thing that's coming, exciting on a difficult way, as well as exciting, in terms of new products, new applications, is going to be energy arbitrage. And you're really only getting the very beginning of it there in Canada. If you look at some of the other utilities the world over, if you look at, say, Europe, for instance, where they're beginning to see the influx of solar actually impacting their grid, and there's kind of been a knee-jerk reaction to stop all net metering, require smart grid inverters, require electric cars to be able to mitigate grid issues, things like that. We can assume that a lot of those are coming to the U.S. and Canada as well. And indeed, today in Hawaii, in California, and also seeing some of it in Ontario, you've got things from circuit restrictions for PV. You've got utilities levying demand charges based on the peak kilowatt demand at any one point in a month or a year. Different ways they calculate your bill based on those demand charges. Peak times of use, essentially peak charges, some of these other billing mechanisms that the utilities use are oftentimes meant to be an economic signal to their customers to reduce their impact on the grid. Sometimes, say in California, it may be because the weather report has a day looking like it's going to be 106 degrees, and the utility already knows what the load is when all those air conditioners come on. And so just as an example, California has, I believe, 14 events scheduled for this summer where they will actually charge $1.09 above the peak rate per kilowatt hour for usage on that time. There's certain customers, depending on the schedule that they're on, they may be charged $1.48 a kilowatt hour during these quote-unquote events in California this summer. So obviously there's quite a bit of money that's going into buying that electricity. It makes the return on investment a lot more quick. As the utilities in California, Hawaii, Texas, New York, Massachusetts, Ontario, Europe, as they get used to these billing mechanisms and they start implementing them with success, you can guarantee that the other utilities are going to follow suit. Another very interesting thing that is coming with this, though, is that there's going to be options available to interact with your utility power, with your PV or your battery system, and provide essentially resiliency to the grid. If you read industry rags from the utility side, they basically say that the majority of the North American grid needs to be replaced in the next 10 years. We have a very old grid. We've gotten very used to having the lights turn on when you flip the switch, and so we're super spoiled. And yet the utilities believe that virtually the entire grid needs to be redone almost from the ground up. A big reason they believe this is because they're looking at the increased demand, the increased distance that the demand is from the generation, and they're thinking about infrastructure upgrades that are going to be needed to carry that much power out to the furthest reaches of the furthest circuit and maintain it within the ANSI limits. You know, we've got a 60 hertz grid. Well, they're never allowed to go below 59.7 hertz on our grid, or they're outside the ANSI limits and they get fined, at least in the US. I believe it's all in North America. But essentially, they've got voltage and frequency limits. Every time they have to push that power further out one of those circuits, they have more and more difficulty keeping it within those limits. Well, the answer is energy storage and a grid interactive smart inverter like the Radiant. Essentially, you are seeing this already different ways. Hawaii, for instance, if you put a PV system in, You essentially have to have this built into the inverter, and the utilities wrote the rules in such a way that the customer buys the batteries and the utility is getting the benefit from the batteries. We don't like seeing that. I don't think the customers do either. And if you look at California, on the contrary, they basically have a deregulated scheme where even a homeowner, depending on the type of utility they have and what the options are, can sell some of this energy arbitrage off of just the homeowner's system. Now the Radian, the FXR, like you have in these three-phase inverters, these are all capable of doing exactly what the utility demands while maintaining the best case scenario economically for the customer, by being agile enough to change the way that they operate based on the rules changing. So today, this may just be a backup system. You may have time of use, let's say, and it may be a high enough priced tier in the mid-afternoon that you decide you're just going to take most of your facility off the grid for 3-4 hours in the afternoon and then go back to a backup system all the rest of the time. For that matter, you may have a demand charge that you want to get rid of, and you can tell our system to limit the demand that it sees from the grid to a certain number of amps. Now, with all of these systems, you can also use our optics online monitoring and control system that not only allows you to see your system in a pretty little format that is very end-user friendly, but you can also dig into a ton of graphing. You can do the programming on optics. You can change the mode of operation several times a day. And if you actually get into some of our inner menus when your utility is requiring some of these things, you can get into all the smart grid applications as well as receive a signal from the utility to help support voltage or frequency, things like that. So this is already miles beyond what most of you are experiencing today, but these systems have their benefit today, and they will have more benefit in the future. So you're essentially future-proofed if you're putting one of these systems in today. Now for Optics RE, I'll talk to it briefly, but I actually want to give you guys a quick bounce around and show you some of the things that I'm talking about on the actual system. So basically, Optics was built for the installer. The idea behind it is minimizing the number of hours of windshield time or calls that you're going to have to take to go out and check on a system that a customer has installed. Also, it gives our tech support a great access point to see what's going on with the system if there is a problem. And on that note as well, HES is also a great place to start, and I do know that they can help you with the minimal problems. So if you give them access to the optics system as well, there's several layers of technical support that are available to you that in the past would just be someone on the phone trying to understand exactly what you were looking at. For the end user, the system owner, there are 4 different levels of security that the installer can set on optics, and the top level allows the system owner to get all the pretty stuff. They get the weather map at the top, they get a dashboard that shows whether they're consuming or producing, shows the power flow, including all the components in the system, if the grid is there, if it's off grid, if there's a generator, no generator, so on and so forth, as well as they can look at some of the graphs, look at their production as far back as 5 years, essentially watch the life of their batteries, get a more clear understanding of maybe how they're using those batteries. Maybe they hooked up a couple of circuits in case of an outage. They hooked up the most critical ones, and they've got a day-and-a-half outage, and they realize that they barely tapped their batteries and they can back up a little bit more. Lots of good reasons to be able to keep in touch with their system on optics. And then, of course, the communication between them, their installer, and Outback is much stronger. So I'm going to jump right into optics here, and we're going to kind of show you how some of these fit together. So when you first get into optics as an installer, this is what you'll be looking at. You essentially see a map that scales to the systems that you have. For me, I've got access to a few different systems, but the one that we want to look at here is the state of Weber. Uh-oh, he's working on his system. Hopefully we can dive in and show you guys everything here. So initially when you're on optics, this is what the weather is actually like here today. It's very odd for us in Western Washington. Lately we haven't had much of this, but we're known for it. So very often this is what it looks like around here. Now, if he wasn't working on his system, what you would see here is, since it's raining, it would probably say consuming, and it would show red. If you were producing, it would show green on this dial. He's got a 9.9 kilowatt system, so the most that he would ever be producing would be in that 9.9 range. Of course, in Canada, I know sometimes you guys go past STC ratings on your systems. As the power is flowing, these would actually light up and show you the power moving through. Going to the load, it would tell you how much is there. Going to the grid, how much the generator was on. He's got a voltage showing in his battery. That tells you that it's full. And then as you go down here, we can take a look, and we'll go back a few days because I bet you it was in good shape a few days ago. See what it looked like here. All right, so last week we did have a sunny week, and this is what his system was doing on that day. Now this is the overall system look, and so we've got, you know, all these different pieces that we can add in. Now, solar production, this is what he's got, is the dark green. What he sends to the grid is the light green. I'm not quite sure how he's sending more to the grid than he's producing there, but oh well, that's good for him. What he's using from the grid, you can see at nighttime. He's got a base house load of a little bit under 100 watts, and what is going to the load, those are going to pretty much match up at this point. That might have been, he might have floated his battery a little bit, something like that. And then at the top here, you've got your battery state of health. Right now we're going by state of charge. That means he's got a SNDC in the system, the FlexNet DC. That's also the piece that we were talking about earlier as far as more closely manipulating the SolarEdge inverter for a better charge. So essentially what it's doing is it's measuring amps in, amps out instead of just voltage to understand the health of that battery. If you want to look at it by voltage, that's an option as well. So you can see this is just a backup system. He's not cycling these batteries much. He is a tinkerer of those, so I know that he does tinker every once in a while and run it off of the batteries. And you can also do temperature compensated and see, you know, what the temperature is doing and what the battery is doing based on that temperature. Now, if we want to dive into piece by piece, we can go ahead and look at just his inverters. This was essentially a piece of the graphing that we had a moment ago, but it's not all of it, so that you can get a little more granular. You can see that the inverters are selling to the grid. During the day, they've got excess production selling to the grid. By the time we get down here, we can see that there's very little production. 6:30, 7 o'clock, his base loads are growing a little bit, and so you can see that he's starting to pull from the grid. From you know, essentially 8:30 until almost 7 o'clock, he is offsetting all of his loads with the solar. Now, if we want to take a look at the other side of that, what we have is the production. Now, this is let's see, 3 or 4 charge controllers all combined, and so you've got a nice sunny day, perfect bell curve. Now, if we go and look at these in a couple different ways, these charge controllers are mostly all arrays are pointing the same direction, but there's actually a little tiny bit of variation. So you can see how two different arrays produce slightly differently depending on their orientation. And I can't remember what the difference is. I think they're both south, and one, I believe, is slightly southwest. Now, if we go over to the battery, we can see kind of what essentially is happening to the batteries at any one point in time. And you can see that 100 watts is about the most that ever goes to the battery. Basically, with a system like this, most of the time you're just floating that battery. You may see, in a course of a day, you may see a little bit going to the battery almost all the time, but it's very minimal, and it's not really going to take from your production. So that's what we have on the graphing section. Now we'll get into, that's essentially everything that the end user customer would have access to. So now let's get into some of the deeper stuff that we were talking about in terms of how you can use this thing. Now, when you're first setting the system up, this is where you're going to end up going. You're going to add in any photos of the installation that you might need to prod your memory when you get on the optic system 2 years later and the customer's wondering what's going on. Kind of give you a layout of the room they're in and that sort of thing. Same thing with the notes. Anything that you might have had to remember later, you can put it in there. The alerts is very interesting because you can essentially tell your system to let you know what's happening when. And if it's something you need to know right away, you can tell it that you need to know immediately. You can have it deliver hourly or daily messages as well. And we can't get in here because he didn't let me make changes to his system, because otherwise I probably would mess around with it and give him fits. But if you do say we change this to immediately, it will also ask you whether you want a text message or whether you want an email. So any one of these, you can decide when you want it to tell you what's going on and how often you need to know about it. There's about 150 different things here. We don't need to go through all of them, but essentially this is the starting point as well for the grid interactive stuff that's coming, where you can essentially tell this to do a specific action based on what's happening with the utility. Now, as we okay. Now, if we go into the devices, same thing we were looking at with the customer before on his view, where you have all the graphing and everything, but here we're just listing them, and it's telling us what port they're in this hub 10.3, and we have the option to jump in there and configure them. Once we dive in, any one of these things has a number of different applications that you can use. Also tells you right from the beginning overall system information. It's a 48-volt battery bank, 9.9 kilowatt array. That's the type of stuff that you add in as when you first set this system up. And then you can take a look at the site. Profiles is actually where you would invite the customer. Once again, always set it up yourself and invite a customer. Otherwise, they have full access to it. And then as well, it tells you what's exactly going on in the system here right now. Now, go away. Now, the next interesting piece, and this is where we really get into a lot of the programming. We go to the device map. So again, same list we saw before, 8048, it's actually a 4048, couple charge controllers, FlexNet DC. What we really want to get into here is the Mate 3. Now, remember we talked about some of the grid interactive stuff. We talked about the different modes that are available to use. Well, in here, you can, okay, there's 6 different modes, and unfortunately, I guess it's not accepting my changes right now. Bummer, I really wanted to show this to you guys. The modes that you would see there, I guess at least I'm showing you where it is, would be grid tied, backup, UPS, generator, grid zero, and mini grid. There's one more I'm forgetting. But essentially, they give you the opportunity to tell your system how to act. Grid Zero, for instance, is a mode that will never sell back to the utility, uses only renewables to charge your batteries, and is trying to act like you're off grid. So using whatever portion of your batteries in your solar as you give it every day, and then only using the grid to support everything beyond that. Mini grid, very similar, except it will use the grid to charge the batteries, and it's an all or nothing, whereas Grid Zero will blend utility power with PV power. Mini grid essentially is going to either be all grid or all PV. The other piece is that Grid Zero is always pulling 1 amp from the grid. Now there's a couple of modes. Oh, support mode, that's the one I forgot. So there's a couple of modes like that where for these commercial 3-phase systems, they have a particular way that they're helping to manage your bill. Support mode, for instance, is the way that we get rid of demand charges or reduce demand charges. Now, depending on how demand charges are calculated, very typically it's strictly based on a number of amps that are pulled from the grid at any one point in time, and you either pay for that highest delivery in one lump sum at the end of the month, or depending on where your previous 12 months history had their highest demand, it may affect your overall billing. What support mode can do is it can make sure that you stay below a certain amperage limit on what you're drawing from the grid and support everything else with the inverter system. Now, a couple of interesting things about the way this operates, and I'm not sure that today there's a ton of application in Canada for this, but it is coming. Time of use, for instance. Now, say you have a 6-cent kilowatt rate in the evening or in the nighttime, and during the middle of the afternoon, the billing mechanism that they want to send to their customers is to stop using as much power as you can, and so the rate jumps to 25 cents a kilowatt hour in the afternoon. Well, what you would do is you would go here to flex time, and you would set up these intervals. And you can do 3 of them today. In the future, this will be infinite as well. But you can essentially say, all right, let's go to off-grid. You know, let's take the system offline. Couple different ways that you can do that, but the easiest one would be to change to, say, mini grid mode or one of the other modes that does not allow sellback for those peak times of the day. And you'd be running off a battery instead of buying your grid power at 25 cents a kilowatt hour. In the middle of the night, you may go in here and say, okay, we're going to set my timer to start at 8 p.m., which is what, 20 hours, 0 minutes, and we're going to go to grid tide. I want to bring the power all the way back up in my batteries on that 6 cent a kilowatt hour rate, and by the time I hit 8 in the morning, I want to be ready to use my system again. Now, maybe at 8 in the morning, there's some other thing that you want to do. Maybe it's strictly staying in grid tide in the morning because your batteries will be full and the utility allows you to sell back. I don't know, but essentially you can change up to 3 times a day here, and the mode changes with it. For the AC coupled, this is where you would control that. It's absolutely this easy. Disabled, enabled. That's when you're using the OBR-DIN relay. Essentially, it's already recognizing the voltage that you tell it, and so you're just enabling it in here. HBX is a function of the mate. This is another one that can be used similarly for peak times of day. Essentially, what this does is it allows you to use as much of your battery as you tell the system to use before it reconnects to the grid. So it will take you off grid. High battery transfer is what the HBX stands for. And it says, if I got a full battery, I'm going to use it down to such and such a state of charge to power all of my loads. And when I hit that state of charge, I'm going to reconnect to the grid. Let's see. couple other things in here. With the FNDC in the system and multiple arrays, like we were talking about there, you will be able to also set your charge controllers to have a global charge control, so they will all switch which charge cycle they are in at the same time. If they're not set up that way, they will each go through their own bulk charge. When they hit the target, they will start the countdown for absorb. They may see that target as differently as, several minutes, depending on how things are set up. And so they may still be doing an absorb when the other one goes to a float charge or things like that, especially if you're using something like HBX, or if you're using mini grid mode, or any of those modes that have to do with state of charge on the batteries. Also with AC coupling and telling the SolarEdge inverter when to turn on and off, it may be important to have a charge, I forget what they call it, charge termination control, which is a function of the FNDC. Keep in mind with the FNDC, of course, we'll tell you this if you have to call in and use it for stacking these systems with the SolarEdge inverters, so on and so forth, but always make sure you have 100% state of charge in your batteries when you first set that thing up, because whatever it sees for the state of charge at the beginning, that's what it assumes is 100%, and so it will always try and bring it back to that point. If it's really only 80%, it's just going to try and bring the batteries back to 80%. So I've gone through it. I'm sure there's some confusion here as well, so let's go ahead and hop right into questions. I will throw the one more caveat out that I'm not the most knowledgeable on this. I know a bit about it, and I've sat through a few webinars, but if I have to, I will take any questions that you have. Go talk with Mark Mays, who wrote the application note on this, and make sure you get a good answer.
Right on, Kendall. Thank you so much for the presentation. I got a quick question. Do you know the time of day settings where you can change from grid to battery?
Yep.
What happens if there wasn't enough battery power to keep going during that time?
Those would be settings that you would input. So let's say, for instance, and really you could set up your operations so that would never be an issue as well, because you could always charge from the grid. We're talking peak charges type of thing. You could always charge from the grid off peak and make sure you have a full battery. But you would set up your battery regardless, so that your state of charge at the bottom of your spectrum is a hard and fast point. So let's just say, as a for instance, you have 80% of your battery left. You told your battery don't go below 60%. You've got a peak rate that you go into at noon, and you tell the system to start going off the battery because you're getting charged peak rate. Well, you've already told that battery, when you hit that 60%, I want you to stop using HBX or stop using whatever mode we were using to take you off the grid. So you would automatically put the loads back on the grid. But there's one more logic function in there as well. Do we have the charger on or off? Do I want to recharge my batteries from the grid at that point as well? And depending on the rate that you're paying, you may have that charger off, in which case, if you have solar, it will always use the solar to recharge the batteries. But with or without the charger, you may or may not use the grid to recharge them.
Right, so you can really fine-tune it.
Absolutely.
Right on. That's a really cool feature. If there's any other questions, feel free to come in right now. Otherwise, it looks like we've got a quieter crowd today. So you obviously did an excellent job in your presentation, Kendall.
Or I just confused everybody.
One of the two. One of the two. I like option one better. But if there are any questions and you haven't had a chance to type them in, please send them to us here at HES, or even to Kendall as well. I'm sure he'd appreciate it. And we really appreciate everyone coming down today and joining us for this presentation. We're always here for help and obviously product as well. Thanks again, Kendall, and we look forward to your next presentation and more like this.
Perfect. All right. Well, thank you so much.
Okay. Thanks, everybody. Have yourselves a great day. Cheers.
Bye.